Welcome to Unit 5, Lesson 7, Interpreting and Using Exponential Functions Practice Problems. Okay, the half-life of carbon-14 is about 5,730 years. A fossil has 6 picograms at one point in time. Which expression describes? All right, so 6 is our original amount. 6 is our original amount. Half-life, our rate is half. T over, that's a T. 5730 is our equation. So A is the correct answer. Okay, the half-life of carbon is about 5,730 years. A tree fossil was estimated to have about 4.2 when it died. The following now has 0.5. About how many years ago did the tree die? All right, so what we're going to do is look at 0.5. That's our answer. This is the answer we're looking for. I'm going to take it out to 4 numbers. So I'll just put 3 zeros at the end of it. So 4.2 is our original amount. It says half-life, so that's our rate of change. And then x over 5730, and where x stands for time. You're going to put this into y equals into your calculator, and then hit second graph. And if you don't remember how to do the exponent, you hit the caret button. So you're going to do 4.2 parenthesis, which is over the 8, 1 divided by 2, close the parenthesis, hit the caret button, which is over the division symbol, then put xt theta in, which is under the green button, or is to the right of the green button, and then divide it by 5730, hit second graph, look at the table of values. Okay, so when we did this one, you're looking at numbers 1, 2, 3, 4, 5. Our half-life is 5730. So what you're going to do now is go second window, and then the first thing is table start. Leave that at 0. Now, delta table. This is the one you want to change, the change in table. We want to change this to 5730. So 0 is 0, 1 is 5730, 2 is 11460, and then 3 is 17190. So make sure you change delta table by hitting second window. And then hit second graph again. And then you'll see 0 is 4.2, 5730 is 2.1. At 11,460 years, you're at 1.05. And at when x is 17,190, that's your time. Y is, this is your grams, 0.525. Since 0.525 is close to 5,000, it's a little bit more. It's about 3 half-lives. Which is more than 17,190 years. So we can get closer to that, and we're going to learn something next week that gets us much closer. But this is the closest we can get with these numbers. Okay, nickel is a radioactive substance with a half-life of about 100 years. Okay, we have 9.8 milligrams of nickel rated in years. So 9.8, our rate is 1/2. Half-life is about 100. So T out of 100. So when T turns 100, you get a full half-life. So that's our first one. So now for days, how many days in a year? It's the same equation. T to 100 times 1 year is 365 days, giving us 9.8 1/2 T 365, and put 2 zeros at the end because we're multiplying by 100. So this is our exponent, T over 36,500 for days. Tyler says that the function 5 to the x power is exponential and grows by equal factors over equal intervals. He says that the 10th root of 5 must be an interval of 1/10. Do you agree with Tyler? Yes, Tyler is correct. So the 10th root of 5 is equal to 5 to the 1 over 10. This is an exponent law, changing a radical to an exponent. Okay, the population of a city is modeled by P of D equals 100,000, 1 plus 0.03 D, where D is decades. All right, so D stands for decades. That's important to know. All right. Now, what are the 0.3 and 100? The 100,000 is your initial population. And then 0.3, remember, we cannot put percentages into these types of exponentials. So we multiply it by 100 to get 30%. And this is the growth. It's 30% on top of our original amount, which we add to 1 because 100% equals 100,000. And we add to make it grow. Write an equation. All right, so write an equation. So P of D in years equals 100,000, 1.03 to the 1 out of 10, because 10 years is a full growth. Write an equation to represent G to represent centuries. Okay. G is for centuries. Is 100,000. $1.3, so 10 years times C, which is centuries. I should have changed this to C because we're doing centuries now instead of that. And so when you go to calculate these, make sure you change the letters from D, C, or T into X in the calculator. Okay, the function is exponential. Its graph contains the point 0.05. At 0, we're at 5. At 1 and 2, we're at 10. We're at 10 and 5. So what's going on here? Boop, boop. Oh, wait. I'm sorry. I put that dot in the wrong spot. We're going like this. Okay. So this is doubling every 1.5. So 1.5 times 2 equals 3. So that means 5 times 2 equals 10 times 2 equals 20. So then at 3, we're at 20. I didn't draw this too well, but let me draw a better curve for you guys. At 1.5, we're at 10. So this looks linear. It should curve up, but I didn't do too well in spacing out my lines here. So what is an equation that defines F? F equals, what's our start? 0. What's our rate? 2. No, we started at 5. I'm sorry. We started at 5. We started at 5. We're doubling. Every 1.5, we're doubling. Now, we could do a lot of things with the rate here. Since it's doubling every 1.5, we're just going to put x over 1.5. That'll be the easiest way to write this. Okay, select all expressions that are equal to 8 to the 2/3, 8 to the 2/3. So remember, the numerator is your exponent. The denominator is your index. We can write the cube root of 8 squared, which is the cube root of 64, which is 4. So anything that gives us 4. So A works, D works, and F works. And let's look at this again. Oh, B works. B also works because remember, it's the cube root of 8 squared or the cube root of 8 squared. That looks kind of funny, but that is accurate.